the derivative exist for all values of x? What on earth does that mean? It means that for each point x, can I find the derivative of the function? Well, the answer is it depends on the function. The derivative does not always have to exist. And that's why if you read some questions, the question asks you find the derivative of the function where the derivative exists. Okay, I just said does the derivative exist at all points given function? That says it depends on a function, and here's how we can tell. Here is a function. Does the derivative exist at all points? Well, this function is defined for all x except for at x is 1, because look, it's a fraction, and this bottom bit can be 0 when x is equal to 1. And we know if we have a number divided by a finite number divided by 0, you can't do that, so it's not defined when x is equal to 1. So the derivative is not defined when x is equal to 1. In general, if you've got a fraction like this, study the bottom bit. Can the bottom bit, if the bottom bit depends on the input, say x here, can the bottom ever be 0 for some value of the variable, the input? If it can, then the derivative and the function doesn't exist at that point. This is supposing that the numerator is finite, not 0 or not infinity. Another place where you have to start looking at this carefully is if you get something like this, where you remember you can't take square root of negative numbers if we're looking at just real numbers. So square root, so if you have something like x here minus 1, you know that if x minus 1 is negative, then you can't take the square root of a negative number, supposing that, as I said, we're in the we're dealing with real numbers, not imaginary or complex numbers. So then this function will only exist when x is bigger than or equal to 1, and hence the derivative will exist for x bigger than or equal to 1. Alright, now this thing that I've just mentioned here, I've kind of find that especially in school, in schools they not necessarily pay much attention to where derivatives exist. I hope I've shown you here that that's kind of important. So when you write down the derivative of a function, you should state along with it where that derivative exists. Okay, finally, to say that we can have some kind of quite complex functions. The example I've given you are quite basic, quite simple. When we're dealing with special functions such as exponential logarithm, or we're dealing with composite functions, we have different rules to deal with them. So, which will be left to other videos. Now, the main rules are the product rule, which I don't give here. This gives you a formula on how to deal with finding derivatives of functions that are multiplied to other functions. Example: using our basic rules, we can't deal with this case here. This is a function, x plus 1, times this is another function, and we can solve such a thing using the product rule, which is a formula which we'll leave to a separate video. We have the quotient rule. Quotient rules are to deal with cases where we've got fractions. So something, say x plus 1, divided by something else, which involve the inputs. Okay, both involve the inputs of the variable being x here. And this formula to deal with this. Finally, there is something called the chain rule, otherwise known as the rule for the function of a function, otherwise known as rule for composite functions. The chain rule is to deal with cases where we have a composite function. example. Here we have a function being x squared plus 1, and when so x goes into a box, first box calculates x squared plus 1, and the output of that computation is then, let's call that output u. That output then is, we apply another function being power of 3 over 2 to get the answer. So in such a case we can apply what is called the chain rule, which we leave again to a separate video because each of these take quite a while. Alright, so we've given you an overview of derivatives. You know now the difference between what a derivative is, what it means to say differentiate a function, find the derivative of a function. You have some idea of what is a partial derivative. We've just seen some basic rules, and we know there are special rules for more kind of complex kind of functions. Okay, hope this has been useful. If you're interested, follow up on the other videos on differentiation.